the objectives for this lecture, we're going to be talking about excise taxes, which are a particular type of tax, and subsidies. And I want to discuss how these taxes and subsidies impact both the supply and demand curves. I want to talk about the differences between legal and economic incidents, and then talk about the deadweight loss in the marketplace that could potentially arise when taxes and subsidies have been imposed. Governments oftentimes levy excise taxes on market transactions. And for lack of a better way to describe this, think of an excise tax as a payment that the government extracts from a buyer or seller when a transaction is actually taking place. So the tax is levied on a transaction. Some excise taxes that we may be familiar with would be a gallonage tax. So for instance, Illinois has a gallonage tax. Don't quite know what it is, but it's a tax that is paid by gasoline wholesalers, gasoline retailers for a gasoline gallon that they sell. Something that's maybe a bit more close to home for some of us would be cigarette taxes. These are taxes that are levied per pack of cigarette sold or purchased. And these are actually levied on the actual wholesaler. Okay. Some of the impacts or the effects of an excise tax that we're going to review and discuss will be, first off, excise taxes will raise the prices that buyers have to pay for a commodity. And they'll typically lower the price that sellers actually receive for a commodity sold. And we're going to see that this generates what we call a tax wedge. There's going to be a difference between the price that a buyer pays for something and the price that a seller receives for something after a tax is actually imposed. And that's going to lead to what we call a deadweight loss in the marketplace, a topic that you may or may not be familiar with. And of course, the whole purpose of a tax is to generate tax revenue. So we're going to talk about all of these topics in order. In our textbook, the authors refer to an excise tax as really a commodity tax. It's the same thing, just different terminology. Before we start talking about the mechanics of taxation, it's important to define some terms. Beyond just defining what an excise tax actually is, it's important to make a distinction between what we call legal incidents and economic incidents. Now, incidents as a term just defines or just covers who actually pays the tax. Now, legal incidents is about who legally pays the tax, who legally writes the check to the government. Is it the seller, as is the case when you have a cigarette tax, or is it the buyer, as is the case for maybe a sales tax? Economic incidents addresses who actually pays the tax, or who effectively pays the tax, maybe in the form of higher prices paid or lower prices received. This will become clearer as we go forward, but we need to define these terms now. And as we'll see, the economic incidence is really what we're most concerned with in this course, and if the absolute elasticity of demand is greater than the absolute elasticity of supply, then a majority of the economic incidence falls on the seller. Conversely, if the elasticity of supply in absolute value terms, it's always positive usually anyways, is greater than the absolute value of the elasticity of demand, then most of the economic incidence falls on the bottom. And if the elasticities are relatively equal, then the economic incidence is split about 50-50. Okay, so let's do an example. The example here is going to be on taxes on packs of cigarettes. Again, this is a very common excise tax that a lot of states and local governments, even the federal government, have relied on to generate tax revenue and to mitigate smoking behavior. So this is a very, very common excise tax. Let's assume that we have, let's assume that we have a supply for cigarettes, and as an example, at a price of $5 a pack, sellers are willing to sell 100 packs. Now, let's assume that the government levies an excise tax of $3 per pack, and the tax is going to be levied on sellers. So the legal incidence falls on the sellers. Sellers of cigarettes are the ones who, after they sell a pack of cigarettes, have to actually write a check to the government and pay the tax. Okay. Now, the height of the supply curve, as we already know, measures the minimum price that sellers are willing to accept for selling a particular unit of cigarettes. Okay? So for instance here, okay, the minimum price that sellers are willing to accept to sell the 100th pack of cigarettes is $5. Okay? That measures the cost of selling that 100th pack of cigarettes. If a tax per pack of $3 is levied, that effectively raises the cost to sellers per pack by $3. So what we're going to see happening is that the supply curve is going to shift up vertically by $3. Now for every pack that a seller would sell, the minimum price that they're willing to accept is going to be $3 higher. Why? Because the cost to them is now $3 higher. There's the $5 of original cost, the cost of harvesting the tobacco, all the way up to the cost of selling the pack of cigarettes at 7-Eleven. And now there's an extra $3 that is the cost of paying the government $3 extra per pack. So what we see happening here is that for the 100 pack of cigarettes, whereas sellers previously required at least $5 a pack, now after the tax they require at the minimum $8 a pack. Okay? So the question then becomes, well, what does that do to the price of cigarettes in the marketplace? If a $3 tax per pack is levied, and sellers for the 100th pack are now willing to accept no less than $8, does that mean that the price for all cigarettes goes up by $8? And the answer, as you might suspect, or maybe not, is no. The price probably does not go up by a full $3 because demand curves slope downwards. So after a tax after a tax of $3 has been levied, okay, previously for the 100th pack, sellers required at least $5. Now they require at least $8. But notice what happens if sellers try to pass that full $3 tax increase on to buyers, okay, and now try to sell those 100 packs for $8 a pack. Well, at $8 a pack, sellers are willing to sell 100 packs of cigarettes, but buyers, because demand slopes downward, okay, buyers are maybe only willing to demand 50 packs. So we have a surplus of 50 units in this case. Okay? And a surplus, a surplus is going to put downward pressure on the price of cigarettes, and in this example, price is going to reach its equilibrium point, its market clearing point, at some sort of intermediate price between 5 and 8. I'm going to say $6.50, just as an example, and maybe that equilibrium quantity will be about 75 packs. So even though a $3 tax raises the cost to sellers by $3, it does not necessarily raise the price that buyers actually have to pay by $3. Now, this $6.50, this new market clearing price post-tax, I'm going to label PB this is the price that the buyer pays at the store. Okay, this is the new market price. So, after tax has been imposed, I walk into 7-Eleven, ask for a pack of Camel Lights. The clerk says, "Okay, give me $6.50," and I get my cigarettes. They get $6.50. But that's not where it ends. Okay, as a buyer, that's it for me. I pay $6.50. I'm done. But the seller who just received $6.50 now has to take that $6.50 and mail 3 of those dollars to the government because that's a tax. So the seller actually only receives $3.50, as denoted by PS, the price received by the seller. Okay, so what we see happening here is that a tax wedge emerges, and that tax wedge, which is just the difference or a wedge in between the price that a buyer pays and the price that a seller receives, I can note by this green line here. Buyer pays $6.50, seller receives only $3.50. And that difference, $6.50 minus $3.50, or PB minus PS, that's going to be the actual tax itself. So the tax wedge itself actually measures what the tax itself actually was in dollar terms. before we go further, let's reverse this logic and talk about what might happen if the tax is levied on buyers. Now remember what the height of the demand curve measures. Okay? The height of the demand curve measures the maximum price that buyers are willing to pay for a particular unit of output. In this case, my original demand curve, D, which is shaded relatively lightly here, the light blue curve, tells me that before a tax has been imposed, okay, buyers were willing to pay $5 at most for the 100th pack. Okay, that's the maximum price that buyers were willing to pay for that 100th pack. What happens if the government decides to levy a $3 tax on cigarettes, not on sellers, but on buyers? Okay, so now for every time that a pack gets sold, it's the buyer's responsibility to write a check to the government. So the legal incidence in this case falls on the buyers now, not the sellers. Well, what's going to happen is that the demand curve is just going to shift down by $3. Not because the buyer's maximum willingness to pay for cigarettes has fallen by $3, but because the buyer's maximum willingness to pay for a pack of cigarettes to the seller falls by $3. Can you stop that? I'm going to rephrase that.
Sure.
Is that okay? Okay, so when a $3 tax is levied on buyers, what we see happening is that the demand curve, the maximum price that buyers are willing to pay sellers, falls by $3. So now for this 100th pack, buyers were previously willing to spend at most $5. Now they're willing to spend at most $2 in the marketplace. Now, buyers are still willing to pay $5 a pack. $3 is going to the government, which leaves only $2 left for retailers to actually receive. So the height of the demand curve here measures the maximum price that buyers are willing to pay in the marketplace to retailers. Okay. And again, the question is, well, if buyers' willingness to pay falls by $3, what happens to the actual price of cigarettes? Does it also fall by $3? Probably not, because supply curves are upward sloping. So again, initially at a price of 5 and a quantity of 100, we were at equilibrium. Now the demand curve falls by $3 because buyers aren't willing to pay sellers as much for cigarettes, because 3 of those $5 are going to go to the government. So buyers are willing to pay at most $2 for that 100 pack of cigarettes. Well, at a price of $2, sellers aren't so keen on selling 100 packs of cigarettes anymore. In fact, given this example, I'm going to assume that sellers are only willing to sell 50 packs of cigarettes. So, if buyers are really only willing to pay $2 a pack, yeah, they're going to demand 100 packs at that price, but sellers will only be willing to sell 50. That's going to lead to a shortage. Now, eventually, a shortage gets corrected in the marketplace when buyers compete with one another by bidding up the price. And as we can see from this example, the new market clearing price is going to be somewhere in between 5 and 2, where supply and demand intersect. I'm going to say $3.50. So some new post-tax market clearing price is going to be at $3.50, and some quantity maybe $75. Now, the question is this the price that buyer and seller both pay and receive respectively? Well, a price of $3.50 is definitely going to be the price that the seller receives. Again, I'm walking to 7-Eleven. I ask the clerk for a pack of cigarettes. The clerk says $3.50, that's the market price. I pay the clerk $3.50. His or her job is done. I take my cigarettes home with me, but now as the buyer, I need to write a check to the government for $3 more. So even though I pay $3.50 at the counter, I have to pay $3 more to the government. So the price that I actually pay, my PB, okay, is $6.50. And the price that the seller receives, that's $3.50. It's the exact same example as we had before. The tax itself, okay, which is the difference between $6.50 and $3.50, and it's denoted by this green line, okay, is just PB minus PS. $6.50 minus $3.50. Let's quickly compare these two scenarios. In this panel here, if you recall, I have the scenario where the legal incidence of the tax fell on the seller. $3 tax on sellers raised the seller supply curve, demand curve remained unchanged. The price that buyers paid post-tax was $6.50. The price that sellers received post-tax was $3.50. The tax itself, again, as denoted by the green line, $3. Look over here. Here's a case that we just reviewed where the tax was, legally speaking, levied on buyers. Again, that brought the demand curve down, and as a result, after the tax was paid by buyers, their price was $6.50. Sellers' price received was $3.50. Notice that the economic incidence for either of these cases is identical. Post-tax, buyers pay $6.50, sellers receive $3.50. The original price was $5. So, a very, very striking and actually quite interesting conclusion that we can draw from an analysis of excise taxes is that the economic incidence, who actually pays the tax via higher prices paid, in this case the price going from $5 to $6.50 for buyers, or in terms of lower prices received, in this case going from $5 to $3.50 for sellers, that in no way depends on who the legal incidence falls on. Okay? It can fall on sellers, or it can be levied on buyers. In either case, buyers pay $1.50 more, $5 to $6.50. Sellers receive $1.50 less. They receive $3.50 as opposed to $5. Now, to quickly figure out what the economic incidence is of a certain excise tax, you don't need to do all this shifting of curves up and down. We have what we call a tax wedge shortcut. So here I am starting out with my initial conditions, with my supply curve and demand curve, intersecting at $5 and a quantity of just Q stuff, which was 100 in our previous examples. Now what I'm going to do is, I'm going to take that green line, which has a height of 3, and that's my tax wedge. I'm going to start at the left-hand side, and I'm just going to move it over rightward until it just touches both lines. It just touches the very bottom of the demand curve, and at the same time touches the very top of the supply curve. And at that point, okay, we can identify the price that a buyer is going to pay post-tax, $6.50, and the price that a seller receives post-tax, in this case, $3.50. Okay? That's what we call a tax wedge shortcut. So you don't really need to move all these lines to figure out what the post-tax price paid and post-tax price received will actually be. We have this really, really nice quick shortcut that helps us out. Now, to calculate the actual economic incidence on buyers, all you do is you take the price that the buyers paid post-tax, PB, in this case $6.50, subtract from that the price that they would have paid pre-tax, in this case $5, and divide by the tax itself, in this case $3. So $6.50 minus 5 is $1.50, over 3 is 50%, 0.5. So when it's talking about economic incidence, who actually pays a tax, one way that we can state this is that buyers pay 50% of the tax in the form of higher prices paid, regardless of who the actual legal incidence is imposed on. Conversely, to calculate the economic incidence on sellers, we take the price that they would have received pre-tax, that's $5 per stuff. Subtract from that the price that they received post-tax, that's PS, in this case $3.50, and take that difference and divide it by the tax itself. So in this case, I've got 5 minus $3.50, that's $1.50, divided by 3, also 0.5, or 50%. So we would say in this example that 50% of the tax is paid by sellers in the form of lower prices received. They receive $3.50 as opposed to 5. Now, going back to this slide right here, notice that the slope and the elasticity, I'm going to say, of both supply and demand are relatively equal. Which means that, given this example, the economic incidence of a tax was split about 50-50. But what happens if the elasticities are not relatively equal? What if supply is more elastic than demand, or what if demand is more elastic than supply, relatively speaking? So for instance, what happens if the elasticity of demand for cigarettes is very, very high in absolute value terms relative to the elasticity of demand for, relative to the elasticity of supply for cigarettes. Well, again, use your tax wedge shortcut. Here's a new demand curve, much flatter, much more elastic. The supply curve hasn't changed. I'm going to take that green tax wedge of $3, start over here, and move over from the left, so move right until it just touches both supply and demand at the same time. And at that point, I can identify the price that buyers are going to be paying post-tax, the price that sellers are going to receive post-tax. And as you can see, starting, kind of compared to P star, which was the original price paid and received, sellers incur a much deeper discount. Right? The price that they receive post-tax is much lower relative to the price that the buyers pay post-tax. So in this example here, because demand is so elastic, and as a result, it's harder to pass on a tax increase onto buyers, most of the economic incidence of a tax is falling on sellers. Far more than 50%. I have this example here of Coke versus Pepsi. The elasticity of demand for two very close substitutes, in this case Coke and Pepsi, is going to be very high. So if the government were to tax Pepsi alone and not Coke, it would be very hard for sellers to pass on that tax increase onto buyers of Pepsi. Oh, can you stop that again? I forgot what I said there. Can you just stop it? Sorry. So for instance, if the government were to tax Coke and not Pepsi, two commodities that are very close substitutes in consumption, it would be very hard for sellers to raise the price of Coke and not raise the price of Pepsi, and really keep buyers in the Coke market. A lot of consumers would just flood to the Pepsi market because Coke is relatively more expensive. As a result, sellers have to take the hit and incur most of that tax in terms of lower prices received. As is maybe a bit more realistic for the case of cigarettes, if the elasticity of demand is very low relative to supply. Maybe this is because, as is the case with tobacco products, maybe buyers are addicted. We're going to see that most of that economic incidence of the tax is going to be falling on buyers. Again, take that green tax wedge, start from the left, move over until it just touches both supply and demand curve. And at that point, you've identified the price that buyers pay post-tax, and the price that sellers receive post-tax. And as you can tell, most of that green line is going to be falling on buyers. Sellers do incur a small reduction in the quantity, in the price they receive, but nothing in compared to the higher price that buyers pay post-tax. And again, we know that cigarettes are very expensive in states that have high cigarette taxes, because sellers can easily pass on cigarette taxes to buyers, because buyers are addicted. There's not a lot they can do, at least in the short run, to escape paying a higher price. Now, of course, governments levy taxes so they can collect tax revenue to pay for public goods and services. The way that we calculate tax revenue is just the tax rate itself, which I abbreviate as T. So in our example, T was $3 a pack, times QT, which is the quantity of packs sold post-tax. So revenue is just T times QT. The tax, again, is just that green line, that's T, and QT is the quantity bought and sold post-tax. So base times height, the area of that salmon-colored rectangle, that is tax revenue. So in an example where the tax is $3 and the quantity post-tax is 500, 3 times 500 is $1,500. That's the tax revenue that the government would collect in this particular scenario. Now, notice also that the price that the buyer pays is a lot higher than it used to be, and the price that a seller receives is a lot lower than it used to be. So as you might have already kind of picked up, the consumer and producer surplus post-tax will be a lot lower. Remember, when calculating a consumer surplus, you're looking for the area below the demand curve, above the price paid, which in this case is just PB, and up to the quantity purchased, which in this case is QT. And when calculating or when visualizing the producer surplus, you want to look for the area above the supply curve, below the price received, which in this case, post-tax, is PS, up to the quantity sold, which in this case is QT. So you have a much, much smaller area for both quantity, a consumer surplus and producer surplus. Some of which they might get back in the form of public services. So we don't really treat that pink area as lost surplus. It's not really consumer, it's not really producer, it's just a transfer. But notice that there is what we call deadweight loss. Okay? Notice that post-tax quantity bought and sold is only QT, whereas pre-tax, the equilibrium quantity demanded and quantity sold was Q star. So, for each of these quantities in between QT and Q star, notice that the height of the demand curve remains above the height of the supply curve. Each one of these commodities in between QT and Q star, buyers are willing to pay a price above what sellers are willing to accept. So, presumably, pre-tax, there is a price in between, okay, this blue and red line that buyer and seller can agree on that will make them both better off for these transactions. But because of the tax, okay, these transactions don't actually occur. So, think of this gray shaded box as what we call a deadweight loss to society due to lost gains from trade. Okay? There are gains from trade to be had from these transactions, but because of the tax and the tax wedge, buyers are not going to be willing to pay the price required for these commodities, and sellers are not really willing to accept the prices that buyers are willing to pay for those commodities post-tax. So these transactions will never actually occur. Now, this is under the assumption that the full benefits and the full costs to these transactions are 100% internalized by buyer and seller. Later on in the semester, when talking about market failures, in particular externalities, we'll see that imposing taxes doesn't always lead to deadweight loss, such as it's described here. But that's for a later time. Can you stop, please? Just real quick. Okay. So, if you can understand taxes, excise taxes, then you're not going to have too much of a problem understanding subsidies, because they're really just the flip of a tax. Okay? Subsidies are just payments that the government makes to buyers and sellers, as opposed to payments that the government extracts from a buyer and seller. In the United States, some of the most common subsidies around are agricultural subsidies, housing subsidies, education subsidies, housing subsidies, I think I said maybe. And not unlike the case with a tax, but flipped a little bit, okay, the effect of a subsidy will be that it lowers the price that sellers actually incur when producing something. And it actually raises the maximum price that buyers are willing to pay for something. So it's the flip. And it will generate a deadweight loss, but due to excess production and consumption, not due to too little production and consumption. My slides are frozen. Something happened. Okay, so let's go back to the case where we start with the seller. Okay, so this lightly shaded supply curve, this is our original pre-subsidy supply curve, where in this case I'm talking about cotton, because cotton is an agricultural commodity that has received a lot of subsidies in the past, and I think it probably still does actually. Along this original supply curve, at $10 a bushel, which is the unit of measure for cotton, sellers, let's assume, are willing to sell 100 bushels of cotton. Another way of looking at that is that the minimum price that sellers would require to sell that 100th bushel is $10 a bushel, is $10, which measures the full economic cost of bringing that 100th bushel to market. Now, let's assume that the government decides to subsidize cotton by offering sellers $2 for every bushel that they produce. Effectively, what that's doing is it's offsetting $2 of the cost to sellers for producing each bushel and bringing it to market. So that's going to shift the supply curve down by $2, vertically speaking. So whereas sellers required at least $10 for the 100th bushel pre-subsidy, post-subsidy, they're only going to require $8 at the bare minimum per bushel. Again, why is there a $2 difference? Because two of those $10 in costs are being paid by the government. So effectively, their costs have been reduced by $2. Now, as you might have already gleaned from the tax discussion, just because sellers are willing to sell cotton for $2 less doesn't necessarily mean that the equilibrium price is going to fall by $2. Because remember, demand curves slope downward. So take a demand curve, assume that the original $10 100 units point was the original equilibrium point, and notice that if sellers were to sell their cotton for $2 less, okay, a bushel, at that price of $8, consumers, buyers, demanders are going to be willing to buy more. In this case, maybe 150 bushels. So there's going to be a shortage at $8 a bushel. Now, over the long run, how the market responds to a shortage is that buyers begin to outbid one another by putting upward pressure on price, and eventually what's going to happen is that as price gets pushed upwards, we're going to move up along the demand curve, and sellers are going to increase their quantity supplied a little bit, and eventually the new market price will converge somewhere in between 8 and 10 at this new equilibrium point, let's say 9, just right in the middle. And the new equilibrium quantity will be 125, right between 100 and 150. So, the new market price will be $9, okay, which is the price at the counter. So, I walk into a cotton retailer, maybe I'm a big clothing manufacturer and I buy cotton in bulk, and the retailer charges me $9 a bushel, okay, and that's the price that I pay as the buyer. That's it. My job is done. But as a seller, I take that $9. I take that $9. Okay, keep the receipt. Mail it to the government, and then they're going to mail me in response $2 in subsidy. So as a seller, even though I get $9 at the counter, I really stop.
I got a boogie.
Okay. Okay. So the minimum price that sellers are willing to accept falls by $2, and that does not really mean that the price at equilibrium falls by $2 because demand curve slopes downwards. At the price of $8, we see that there would be an actual shortage. That's going to lead to an upward pressure placed on price, and the new market clearing price will be somewhere in between 10 and 8. I'm going to say 9, and a new equilibrium quantity of about 125. Now, this $9 is the new market clearing price. So as a buyer, that's the price you pay. That's it. But as a seller, okay, once you sell a bushel of cotton, you get that $9 from the buyer, plus you get $2 from the government. So as a seller, you actually receive $11. Buyer pays 9, seller receives 11. I'm using the exact same notation as before with the tax lecture, but notice now that after a subsidy, sellers receive a higher price, not a lower price, and buyers pay a lower price, not a higher price, relative to the original equilibrium price of 10. And this green horizontal bar, that is the subsidy itself, which is just calculated as a difference between the price sellers receive post-subsidy minus the price buyers pay post-subsidy. We have the exact same story if we have a subsidy given to buyers. So let's assume now that instead of a subsidy being given to sellers, the subsidy is given to buyers. So for every bushel they buy, the government's going to pay them $2. What happens then? Well, if the government's going to pay me $2 for every bushel that I buy, that effectively raises the maximum price that I'm willing to pay for a bushel of cotton. So initially, I was willing to pay at most, along this light-shaded curve, $10 for the 100th bushel, but now because the government's subsidizing me, and I'm getting $2 more to spend, now for that 100th bushel, and for all the other bushels as well, I'm willing to pay $2 more, in this case, $12 a bushel. But again, that's probably not going to lead to a $2 increase in equilibrium price because supply curves slope upwards. So even if buyers are willing to pay $2 more and still demand 100 units, at that $2 price increase, sellers are going to increase their quantity supply from 100 to 150. That's going to lead to a shortage, which in the long run puts downward pressure on price, and prices that we see will converge to this new intersection of supply and demand, somewhere in between 12 and 10, let's say 11, and a new quantity of, again, let's say 125. So now we have a new price at the counter of $11. This is the price that sellers are going to receive, and that's it for them. Buyers, on the other hand, get $2 off via a government subsidy. So even though they pay $11 at the counter, they're going to get $2 back from the government. So the price they actually pay is $9. The exact same outcome that we just saw when the subsidy was levied on sellers. So we end up with a price received by sellers of 11 and a price paid by buyers of 9. Again, this is no different than the case we just saw when the subsidy was levied on sellers. The only difference is that in one case, the supply curve is moving down, in the other case, the demand curve is moving up. But the end result, $11 to sellers, $9 to paid by buyers, is the same. The economic incidence of a subsidy is unchanged, regardless of the legal incidence of the subsidy. Now, the same way that we did with the tax, there's a shortcut, a subsidy wedge shortcut, if you will. And all you do is you take that green vertical line, which measures, vertically speaking, the actual subsidy itself, start from the right and move leftward until it just touches the supply and demand curve. And at that point, that's going to tell you the price that a seller receives post-subsidy and the price that a buyer pays post-subsidy. Now, if you compare those to the original P star, the original pre-subsidy market price, you'll see that the incidence of the subsidy, in this case for buyers, the economic incidence, is calculated as the price that they would have paid pre-subsidy minus the price they paid post-subsidy divided by the subsidy itself, which in this case is going to be, what, 10 minus 9, which is 1, divided by 2, which is 50%. Same thing for sellers. You take the price that they receive post-subsidy, subtract from the price they would have received pre-subsidy, so in this case, 11 minus 10, which is 1, divide by the subsidy itself, and you get 0.5, which is 50%. So in this stylized example here, both buyer and seller, economically speaking, pay half the subsidy. Okay? Now, look at consumer surplus. Remember, area below the demand curve, above the price paid, which is now a lot lower, up to the quantity purchased, which in this case I abbreviate as Q sub. So this is the quantity bought and sold post-subsidy. The triangle is a lot larger now than it once was because buyers are receiving a lower price and they're buying more units. For sellers, it's the opposite. Okay? They're receiving a higher price than they once would have. So, again, area above the supply curve, below price received, up to quantity sold, that's this green triangle right here. So both buyer and seller benefit from the subsidy directly. Now, of course, that subsidy costs money, usually via tax revenue. What does the subsidy cost? Well, the subsidy just costs whatever the subsidy itself is. I abbreviate that as sub. That's just the height of the green bar there, multiplied by the number of units bought and sold post-subsidy, which in this case might be $2, again, height of the green bar, times 125, which is what 250. That's a typo. That should be 250, not 150. So, even though surplus for both buyer and seller increase, the cost of subsidy is going to offset some of that. And what we see happening is that there ends up being a little bit of deadweight loss right here, which reflects the fact that when you have a subsidy, you end up producing too much relative to the equilibrium quantity. For all of these quantities, in between Q star, which is right here where the two lines intersect, and Q sub, the cost of producing those units exceeds the maximum price that buyers are willing to pay. Which means that for each of these quantities, society effectively wastes resources. And that is the deadweight loss generated by a subsidy. And again, a little disclaimer here, this all this deadweight loss discussion revolves around the assumption that costs and benefits of economic decisions are fully internalized by buyer and seller. This is something that we'll discuss more in depth when talking about externalities. And that is it.